Cloud concepts and techniques. Cloud computing encompasses various concepts and techniques that enable the delivery of on-demand computing resources over the Internet. Here are some key cloud concepts and techniques. Virtualization. Virtualization is a fundamental technology in cloud computing. It involves creating virtual instances of physical resources such as servers, storage, and networks. Virtualization enables efficient resource allocation, isolation, and flexibility in the cloud infrastructure. Infrastructure as a Service, IaaS. IaaS is a cloud computing model that provides virtualized infrastructure resources, including virtual machines, storage, and networks. Users have control over the operating systems, applications, and configurations on these virtualized resources. Platform as a Service, PaaS. PaaS is a cloud computing model that provides a platform for developers to build, deploy, and manage applications. It abstracts away the underlying infrastructure and provides a ready-to-use development environment, including runtime environments, databases, and development tools. Software as a Service, SaaS. SaaS is a cloud computing model that delivers software applications over the Internet. Users can access and use the software without the need for installation or management of the underlying infrastructure. Examples include email services, customer relationship management, CRM, systems, and collaboration tools. Elasticity and scalability. Cloud computing offers the ability to scale resources up or down based on demand. Elasticity allows automatically adjusting resources to handle varying workloads, while scalability refers to the ability to add or remove resources manually or automatically to meet changing needs. High availability and fault tolerance. Cloud infrastructure is designed to provide high availability and fault tolerance. Redundancy, data replication, and distributed architectures ensure that services remain operational even in the event of failures or disruptions. Data storage and database services. Cloud providers offer various storage options, including object storage, block storage, and file storage. Additionally, managed database services like relational databases, e.g., MySQL, PostgreSQL, and NoSQL databases, e.g., MongoDB, Cassandra, are available to simplify data management in the cloud. Security and compliance. Cloud providers implement security measures to protect data and ensure compliance with industry regulations. This includes data encryption, identity and access management, network security, and regular audits to maintain security and privacy standards. DevOps and continuous integration, deployment, (CD). Cloud computing supports DevOps practices by providing infrastructure automation, version control, and collaboration tools. CD pipelines enable seamless integration, testing, and deployment of applications, reducing development cycles and improving efficiency. Serverless computing. Serverless computing abstracts away server management, allowing developers to focus on writing code without worrying about infrastructure. Cloud providers dynamically allocate and scale resources based on the actual usage of functions or applications. Cost optimization and pay-as-you-go model. Cloud computing offers cost optimization by providing flexible pricing models based on actual resource usage. The pay-as-you-go model allows users to pay only for the resources they consume, eliminating the need for upfront investments and enabling cost scalability. Multi-tenancy. Cloud infrastructure is typically designed to support multiple users or tenants on shared resources securely. Virtualization and isolation techniques ensure that each user's data and applications are separated and protected. These concepts and techniques form the foundation of cloud computing and enable businesses and individuals to leverage scalable, flexible, and cost-effective computing resources.